day. Today we are going to take up the second model for Pythagoras' theorem, and that is given by Perigal. It is known as Perigals dissection model. Now, this is a very old one, but very nice one. You have to be very careful in understanding it, because otherwise it will look like magic, and I'm sure it's going to look like magic. Let's see now. We first make sure that we recall the result of Pythagoras. The theorem of Pythagoras says that if you have a right triangle, if you have excuse me, if you have a right triangle, the sum of the squares on the two sides that form the right angle is equal to the square on the hypotenuse. What do you mean by sum of the squares? How can you add two squares? Area of the two squares. So actually what we want is, and as you know, we have decided to call the hypotenuse C, this is A and this is B. The smaller side is A and the bigger is B. Hypotenuse is C. This means that we want to show that this area plus this area means A square plus B square is equal to C square. And that's what we are going to do now with the help of a model. Now here is the model for it. As you can see, this is the right triangle. Now here is the right triangle, it's like this. I have drawn it this way. This is the right triangle. This is the hypotenuse and this is the square on the hypotenuse. This is our C square. This is the bigger side containing the right angle. So this is B and the area A, view area is B square. And here is the small area square on the smaller side A, and this is A square. What are we supposed to show now? Simple. A square plus B square equal to C square. In other words, this plus this square must fit in here. Now that won't happen very directly, because see, I have cut here a square which is this size. This is B square. Now if I put B square here, there will be some space left here and some space left here, and I can't fit this in over there. We have to do something. Okay, we'll do that. What we do is, we take this square here. In this case, it is this square. We take this square and cut it into 4 parts. Now, as you can see, this is 1, 2, 3 and 4. This is the second one. Up here is the third one, and this is the fourth one. How have we cut it? In a very special way. I'll show you here what we afterwards how we have cut it. Just now I will simply say that we have cut it into 4 pieces. But these 4 pieces are, as you will be able to see, they are all congruent. Not only that, there are some specialties about each one of them. That means all of them. 2 opposite angles are right angles. And on one side of the right angle, the 2 sides are equal. You can see that this side and this side, they are all equal. So, for one angle. Now, what we do is, I'll first go back to it. So these are the 4 pieces. Each one has a right angle that goes in the center and one right angle that goes outside. Outside means at the vertex of the whole big square. Now, we want to fit in everything here. What we do is, we take this one and I'm putting it here. Can you guess now where this goes? Right there. So now, nobody can challenge. We had A square here and B square here, 4 pieces. All of them have fitted in here to make up the whole C square. So that gives us the verification with the help of the model. We want to go over to making of this model because it is not as simple as the other ones where you just make some squares and some triangles. Here we'll go over to it, but before that, even while arranging this, now I could arrange it because I have enough practice in it, but when you try to do it, in order that you don't mess it up, I'll show you a little trick. You can remember it in 2 ways, either way. I'll go back here again. This was the original position. This will go afterwards anywhere. What we do is we take up any one of them. And now the right angle which was in the middle or in the center has to go at the corner. So the inside right angle goes outside. And now if you try to see, it won't go here, it won't go here, it will go only at this place. And the same thing applies to all of them. For this one, the inside right angle has to go outside. It will have to go there. This inside right angle will have to go there, and this one over here. That is one way of remembering it. The other way of remembering it is that we have noted that each one of them has 2 equal sides right here on 2 sides of one of the right angles. The equal sides go outside. That is another way of remembering it. Well, okay. Now over to making it. And in order to make it, I will once again rearrange this. Now essentially what we have to do is simply figure out how to cut this one square. The other square we are not doing anything with it. We are just cutting this one. So we want to know how to cut this big one square. And what I'll do is, I'll first draw this square. I'm drawing only one square, the blue square. Okay, this is the one I'm drawing. I want to fix at this point. What point is this? It is the center of the square, and by the center of the square we mean the point where the 2 diagonals will intersect. Now I don't want the diagonals, so what I'll do is I'll try to put the diagonals just a little bit, and same thing here. That gives me my center. So I have this point now center. From this center, what do we want to do? We want to draw one line and another line, and we know they are at right angles. So once we draw one line, the other will follow automatically. Okay, which one shall we draw first? This one. Look at this. This is the hypotenuse. I'm taking this scale parallel to the hypotenuse, and you can see that the cut that we have made is exactly here, which is parallel to the hypotenuse. So I don't have my triangle here, but if the triangle is like this, I will take a line which is parallel to this, like this, and call it N. I think I'll note down the steps. The first step was, take the center, we'll call it O. Then looking at only one square, nothing else. The square on the side B. So, take the center, O. And I've shown it here, but I'm not writing it. You take the point of intersection of the two diagonals. Then from O, you draw a line L. What kind of a line? Which is parallel to hypotenuse, whose length was C. This was the hypotenuse with length C. We take the line parallel to it. And now the third step is very obvious. We take from O, once again, we take a line which is perpendicular to L. And call it M. We take M, we are taking M perpendicular to L. Now that we have the two lines, everything is ready and we are ready to cut. And if you want to make sure that we do it this way, see, I've taken this, I've taken this square exactly this size, so that we'll be able to fit the 5 pieces here together with the paper cutting. Now what we do is, first step, or you can even, without marking, you can just fold, and where the two folds intersect, I think this will be more exact. This is the center. Here is the center. Now, we take a line from the center. We take a line which is parallel to the hypotenuse. Now here is the hypotenuse. Okay, there you go. Here's the hypotenuse, and we take it parallel to the hypotenuse. And the second line will be perpendicular to it. We know how to take perpendicular by folding. And now we cut the 4 parts. We cut only 1 part, but we get 4 parts now by cutting it. And we have now got as you can see, we have got our 4 congruent pieces. And we shall arrange them here. We knew that this blue, what we can see here is the central point. It has to go outside. So this goes there. Now because this is simple paper, it's difficult to hold it. It falls off. Now, as I just mentioned, the inside right angle goes outside. That is one way of doing it. The other way is that equal sides go on the border of the side of the square. And now, of course, I had cut the smaller square already. That will fit in here. That will fit in here. So that is how you make the model. Once you have your paper cuttings, you know, you can have it on the sponge or on cardboard, wherever, or thick colored paper, as you like it. So we have also seen how to make the model, how to arrange the model, and of course the first thing we saw was how it verifies the Pythagoras theorem. Well, okay, try to cut it yourself, try to fit it in, and when you show it to somebody for the first time, it will look like magic, but it is no magic. We can prove that they have got to fit in. They have no choice. And I'm sure at least the teachers should be able to do it. Okay, thank you and good luck.